recall all the things that I have already discussed in the previous classes. So in the previous classes, we have discussed about 8085 microprocessor. Okay, and if you'll go through your course curriculum, then you will be finding it out that the first unit of your course curriculum is all about the fundamentals of your microprocessor. Okay, so I have already discussed all the fundamentals of microprocessor, that is 8085 microprocessor, and now we are ready for the discussion of our next section of our syllabus, that is our microcontroller. Okay, so from today's class onwards, we would be discussing about a microcontroller, and the microcontroller that we are going to discuss about is our AVR microcontroller. Okay, so this AVR microcontroller is very popular microcontroller which is being used in many different places, and it is having so many functionality within it, and so that is why it is being kept in our syllabus for the discussion purpose. Okay, so from today's class onwards, we are going to start up with our new section that is all about our microcontroller. So before going into the new section of the microcontroller, I would like to ask you that whether the things that I have discussed in the previous classes, are they all very clear in your mind? Or so if it is very clear, that means all of you are well aware of what a microprocessor is, and now we are ready for the discussion of microcontrollers. Yes, so if you are having any kind of doubt related to a microprocessor, you can ask me. Otherwise, we will be starting with our new section of microcontrollers.
Sir,
Hello. Yes.
sir, there aren't any doubt as such, but could you please share your PPT with us so that we can revise and recall?
Yeah, definitely. I'll be sharing the PPT with you. What the things I have discussed in the class, I will be sharing the PPT, so you need not have to worry about it. But the thing that I want to know
No,
at
no,
this point of time is, yeah,
about 8085.
huh?
I'm talking specifically about the 8085 wala PPT.
Okay, okay. I'll be sharing that PPT. You need not have to worry about it. Okay. But if you want any topic to be recovered in 8085, you are free to tell me. I'll be covering the topic once again. No issue. If you want to get a more detailed information about a particular topic of microprocessor. Okay. Because in your course, it is all about the overview of an 8085. Because previously we were having a whole 8085 subject in our course curriculum, but now it has been reduced to one section only, so you just need to get familiar with that what is microprocessor, how it works, and the most basic microprocessor 885 architecture and all that thing is supposed to be covered in your course. So that is why I have taken care that I may be giving you as much as possible information about an 8085 to you. Okay, so let us start up with our today's discussion about microcontrollers. Okay, so I'm sharing my screen with you. Please tell me whether the screen is visible to everyone or not. Okay, so at a starting only, I have told you that yeah, there is a quite difference between a microprocessor and microcontroller, and that is a very important topic generally being asked in your examination, that what is the difference between microprocessor and microcontroller. So probably at a last in this lecture, I will be trying to cover the basic difference between a microprocessor and a microcontroller. But before going into the detail of difference and all that thing, we need to understand what a microcontroller is, because we already know that what a microprocessor is. Now in today's class, we will be understanding what a microcontroller is, and at an end, we would be discussing the point of difference between a microprocessor and a microcontroller. Okay, so the very first question that can be arising in our mind is, why do we need to learn a microcontroller? Okay, so yeah, we know that, yeah, we have seen microprocessor, but now why it is very important for us to learn a microcontroller? Because you will be finding it out that going further, if you want to do post graduation, then there is a special wing embedded system which is totally having a base of microcontroller. Okay, so it is very important for us to study the microcontroller. So we will be seeing that why we actually needs to learn the microcontroller. So it is not an exaggeration if I say that Today there is no electronic gadget on the earth which is designed without a microcontroller. Okay, we want every device to be a smart device, starting from AC to your microwave to your washing machine. Any device, you know, we want the device to be as smart as possible. Okay, nowadays you will be finding it out that yeah, we can have a control over all the gadgets of our home on our fingertip or on a mobile. Okay, so why it is possible? It is only possible because of the existence of a microcontroller. So it is not being exaggerated if it is being seen that there is no gadget without a microcontroller. So we can name them. You can name that communication devices. We can see that yes, there is a microcontroller in it. You can talk about a digital entertainment. It is there a microcontroller. You talk about a portable devices. Yes, we got a microcontroller within it. Okay, you can believe it or not believe it, but yes, there is a microcontroller present in every device where you can find it out a little bit of intelligence in that device. Okay, so these are some of the examples where we can find it out a microcontroller. Okay, so for personal information products such as cell phone, pager, watch, pocket recorder, calculator, yeah, all these gadgets are having a microcontroller within it. If we talk about a laptop components such as mouse, keypad, modem, fax card, sound card, battery charger, again there is an existence of a microcontroller in it. Home appliances such as door locker, alarm clock, thermostat, air conditioner, TV remote, exercise equipment, washer, dryer, microwave. A list is so long. Means in every devices you will, or in every appliances, in every equipment, you will be finding it out of microcontroller within it. Okay. So this is not the limited places where you can find it on a microcontroller. You can find the microcontroller in the industrial equipment also, such as temperature or a pressure controller, a counter, a timers, yes, on basis of which we can have the industrial automation. So the whole industrial automation, the whole home automation, all that particular kind of concepts exist because of the existence of the microcontroller. Okay, you can also find it on microcontrollers in your toys and games such as video games, car, dolls. Okay, I think all of you would have heard about a talking doll. Means you can talk to the doll. The doll will be responding to your question, such as what is your name, what you are doing, all that kind of thing. Yeah, it is only because of the existence of microcontroller in it. So a good designer should always know what type of controller he or she is using, their architecture, advantages and disadvantages. So yeah, we know that there is an existence of microcontroller everywhere around us. So we must be knowing that what would be the architecture of a microcontroller, what are the advantages or disadvantages of using a microcontroller, or how we can reduce the production cost, or how we can increase the product reliability. Okay, all that thing can be done if you are having a very good inside knowledge of a microcontrollers. Okay, so already we have discussed that there can be, okay, at a starting only I had talked about this thing that if you want to add a little bit of intelligence into a system, then there must be an existence of a microprocessor or a microcontroller. Okay, so already we have talked about what a microprocessor is. So just I have defined it that microprocessor is a programmable device that can intake a number, perform an arithmetic and logical operation according to the program stored in it, and then produce the other number as a result. So this was a microprocessor. Okay, so from description already we have gone through this thing, that what a microprocessor is. So we are having an input, a microprocessor, an output and a memory. Okay, inside of microprocessor, this is just a recapitulation of what the things we have seen in the microprocessor. So internally we are having an arithmetic and logic unit, a control unit, an array of register holding data while it is being manipulated. So this is just a block diagram of a microcontroller, microprocessor, that already we have seen. So I'll be quickly going through it. There is an architecture, accumulator, working register, program counter, stack pointer, control, clock circuit, and the interrupt circuit. If I talk about a microprocessor based system, so we can have I/O, memory, ALU, array, and control unit. We have already seen the program execution, but now we need to know that what are the limitation of the microprocessor. Okay, so microprocessor requires an external memory to execute a program. Okay, so whenever we talk about a microprocessor, we always need to visualize that the memory is always available external to the microprocessor. Means we are not having an internal memory of microprocessor. Except some limited arrays, there is no memory. Okay, so what we need to do is always we need to fetch the code from outside of a microprocessor, get it into it CPU, and then the program would be executed. So it is little bit a time consuming kind of a process. Okay, the other thing is microprocessor cannot directly interface with the IO devices such as memory 8255, 8259. Okay, so there are interfacing ICs which are required if I want to add peripheral to the microprocessor. Means we cannot directly interface a memory to a microprocessor. We cannot direct interface an IO devices to the microprocessor. There is always an interfacing circuits, interfacing ICs such as 8255, 8259, 8253. These are the ICs we generally use for interfacing the IO devices or a memory with a microprocessor. Okay. Address decoder and buffer are needed to interconnect the external memory and peripheral interface chip with the microprocessor. That is what I have talked about. 8255, 8259. They are the address decoder and the memory buffers. Okay. There are so we need to get the answer to this question. So is there any device which includes a necessary components like memory, IO ports, etc. within it? Okay, can we think of a presence of a memory inside a processor chip? So yes. So the limitations of a microprocessor gives the existence of a device which we called it as a microcontroller. So a microcontroller is a device and in which we can find it out memory, required memory, IO ports, and all that thing on a single chip. So what a microcontroller contains? So microcontroller contains everything a microprocessor contains, but with that it is also having an extra components on the single chip. So which are these extra components? So the extra components which are on this chip are RAM, which we called it as an random access memory. We can also call it as a read write memory. ROM, that is read only memory. EEPROM, EEPROM. Okay, so we will be finding it out the presence of all this component onto a single chip. Okay, the extra additional things which a microprocessor is not having is a timer. So timer can be used to measure frequency, period, pulse width, duty cycle, or create a delay. So in previous case, in the previous lecture only, we have seen that if I want to generate a delay in a microprocessor, the only thing that I can do is with help of a delay loop by executing an NOP instruction or executing a loop, and by calculating that how many number of machine cycles the loop would be required to get executed, and number of time iterating a loop will generate a time delay. But yes, in a microcontroller we are having a dedicated uh, section which we called it as a timer section, which can be used for generating a delay, to generate or to measure the frequency, measure a time period, pulse width, etc. Okay. With that, it is also having ADC. Okay, now can anyone tell me what is ADC? Hello?
Analog to digital
What?
converter.
Yes, so we are having dedicated analog to digital converters onto the microcontroller, and in some microcontroller you will also able to find it out DAC, that is digital to analog converters. Okay, there can be an DMA also. So can anyone tell me what is DMA? We have
Direct memory access.
yes, direct memory access, that is also available in a microcontroller. In many of a microcontroller, you will be finding out a facility of a DMA. That means if I want to transfer the data from IO device to directly to the memory, it is not required to be fetched into a CPU. Okay, directly that can be. So that is what we call it as a direct memory access. and both the way of interfacing of IOs are possible. You can interface parallel IOs, and you can also interface the serial IOs. So these are some of the additional features which a microcontroller is having except the microprocessor. So in microprocessor you don't find memory, you don't find timers, you don't find DAC ADCs. Yes, you may find DMA, but you cannot find parallel or a serial interface of an IO. We can interface IOs with our microprocessor, but it is only through a chips, that is a interfacing chips. But in case of microcontroller, you need not have any kind of interfacing chips. So let us see what are the basic components available in the microcontroller. You will be finding it out that there are so many different common things where which are available in the microcontroller. So already we talked about an ALU. ALU is nothing but it is arithmetic and logic unit. So yes, arithmetic and logic unit is also available in a microcontroller. We talk about an accumulator. So yes, accumulator is also there. General purpose registers are also there in your uh, microcontrollers. With that, there is an interrupt circuit, clock circuit, program counter, and we can also have the stack pointer. So these are the things which are now already we have discussed in our 8085 microprocessor. Yes or no? Have we discussed all these things in 8085 microprocessor? Hello.
Yes, sir.
So all these things we have already discussed in our 8085 microprocessor. So yeah, we can say that all the things which are present in the microprocessor, they are also available in the microcontroller. Okay, so with that, what are the extra things that we have in our microcontroller? So we directly have a internal RAM, which we call it as a data memory, which is not available in our microprocessor. We have internal ROM, which can be used for programming, storing a program, and that is why we can also call it as a program memory. It is also having an IO ports directly without interfacing without use of any interfacing chip. We can directly have an IO ports in our microprocessor. And the most important feature of any microcontroller is a timer and a counters. So these timer counters, they are not available in a microprocessor, but yes, they are available in the microcontroller. Okay. So already we have talked about the application of a microcontroller. It can be applications such as intercom, toys, VCR, camera, video games, security system, etc. At an home, at an office, we can have fax machine, copier, a printer. So they are also having a microcontroller within it. Automobiles such as engine control, airbag, keyless entry, transmission control, all these things are working on the basis of microcontrollers. Okay, so uh, uh, we need to know, yeah, we find it out that yes, microcontrollers, they are very powerful devices. Okay, so we need to have the selection of a microcontroller because there are a number of microcontrollers available in the market. Okay, so we can have 4-bit microcontrollers. So these are the various manufacturers which provides a 4-bit microcontroller. Okay, now can anyone tell me what do you mean by a 4-bit microcontroller? We already talked about it, that what do you mean by 4-bit microcontroller? Oh, 4-bit CPU or an 8 bits. Okay, can anyone tell me what 8085 if I'm talking about, how many number of bits the CPU can process at a time? Hello. Hello. Hello, 34 number. Hello, 34 number. Hello, am I audible to everyone?
Sir, I think 8-bit.
You think 8-bit? Yes, actually it is an 8-bit microprocessor.
Yes.
Okay, so we can have 4-bit microcontrollers. Okay, so already we have discussed that the number of registers, the number of data lines, they will be deciding that how many number of bit system can process. So on basis of that, we can have 4-bit, 8-bit, 16-bit microcontroller. So if I'll go for an 4-bit microcontroller, so these are some of the companies: Toshiba, TI, Ukai, National, Itachi. So these are the companies which provides a 4-bit microcontroller, and we can see that how many number of pins this microcontroller is having. So if I talk about 8085 microprocessor, it is having 40 pins. Okay, but if I talk about 4-bit microcontrollers provided by this Toshiba, it is different pins for 28 pins, 16-bit, 28 pins, 42 pins. Okay, how many number of IOs that are supported in a microcontroller, that is also a feature on which we can see the microcontroller. So it is 10 IOs can be supported, 23, 11, 23, 35. Okay, how many number of timer controls are there? Timer counters are there. That is, this is one of the most important features on which you are going to make the selection of a microcontroller. So you, yeah, whether it is a one timer control or counter, or two timer counters are there. On basis of that, you can also select a micro. Then there is a RAM, ROM, size of it. Okay, and what are the other extra features? So you can see that over here there is only 32 bytes of ROM. Over here 512 bytes of ROM, 128 2K. Okay, so this is also a feature that can be used for the selection of a microcontroller. Now if I talk about an 8-bit microcontroller, so we can have this many 8-bit microcontroller: Zlog, TI, Philips, Motorola, National, Microchip, Intel. So all this are providing us an 8-bit microcontroller, which are 40 pins to 68 pins microcontroller, and it can support this many IO pins: 32, 12, 24. Number of timer counters: 2, 3, 1, 2, 3, 2. Size of your RAM, size of your ROM, and what extra feature it is having. Okay, at this I'd like to talk about this extra features which we call it as a WTC, because you will finding it out WTC in many microcontrollers. So WTC we called it as a watchdog timer. Okay, so many of time many of time you will be finding it out that our microcontroller may get into an infinite loop in a software. So to get out of this infinite loop from the software, we require a special circuit which we called it as a watchdog timer. So watchdog timers, they are generally being used to get the circuit microcontroller out of the infinite loop in the software. Then we can also have a 16-bit microcontrollers. Okay, so Intel, National. So these are the 16-bit microcontrollers which we can find it out. Okay. Now you will be finding it out this first row. The first row is very important. How many number of pins are there? How many number of IOs are there? How many number of timer counters are there? What is size of RAM and ROM? Basically, we are going to select a microcontroller on basis of these features. Okay. So this is also one of the important question that is generally being asked in your examination, that list out the criteria on which we can make the choice of a microcontroller. Okay. So whenever there is a task of choosing a microcontroller, okay, you will not be understanding this thing, the importance of this thing at this time, but whenever you will be carrying out a project, okay, at that time this thing would be a very important. That, let's say I want to carry out a project and I require a microcontroller in that project, but which microcontroller to be choose for the project? So these are some of the criteria on which we generally make a choice of a microcontroller. So first is the speed. Okay, so what is the highest speed a microcontroller supports? Okay, so that is being depending upon what the crystal you are going to use. But yes, microcontroller datasheet would be providing that what can be the maximum size of a crystal that can be connected with this microcontroller, and what would be the maximum frequency this microcontroller will be supporting for the operation. Okay, the second is packaging, means in which type of package this microcontroller is available. Is it available in DIP, or is it available in QFP, or in some other package. So it is important in terms of space, assembling and prototyping of the end product. Okay, DIP means dual inline package microcontrollers. So I think in digital electronics subject you would have all seen the ICs, 74XX series IC. So all these ICs, they are in the DIP package, dual inline package. The second is what is the power consumption, because we will be finding it out that these microcontrollers are generally used in the standalone devices. Okay, so in standalone devices generally we use battery for the power supply. Okay, battery as a power supply, and yes, the power consumption of a microcontroller will play a very important role in using that gadget before getting the things recharged. Okay, so power consumption, because we are battery backup powered devices, we generally use microcontrollers. So it is very important to know that what is the power consumption of the microcontroller. Then the other thing is RAM and ROM. Okay, so what is the size of RAM and what is the size of ROM? Okay, RAM would be very helpful to you when you are going to store a temporary data. Okay, but ROM, yeah, the size of the code means if you have selected a microcontroller and you have written the code, and now you are not having enough space to store this code in your microprocessor because there is a less availability of the RAM in a microcontroller. So that will be creating a problem. So at an starting only, you need to know that what is the size of your RAM and ROM in your microcontroller. The other is how many number of IO pins are there. So IO pins, how many number of devices you need to connect to a microcontroller, that would be helping you to decide that how many number of IO pins that are required in your microcontrollers. Then timers, that how many number of timers are there. Yeah, you would be knowing the importance of timer once we will be finding it out that how the timers are being used. So there are very wide application of the timer in the microcontrollers. So how many number of timers are available in the microcontroller, this is also one of the major criteria on which you are going to make the selection of the microcontroller. Okay, then the other is upgradability, means how easy it is to upgrade to an high performance or a low power consumption version of the same device. Let's say that you have selected a microcontroller. Now the new release of microcontroller is available in the market, which is very good, means it is having a high performance or either it is having a low power consumption. And if I want to change it, my current microcontroller, with the new upgraded version, so whether I can directly do that or not, so that is also very important, means upgradability is also an issue whenever you are going to make a choice of a microcontroller. And yes, ultimately the cost per unit, means what is the cost of a unit, means what is the cost of one microcontroller, that would be ultimately deciding the cost of your product. So that is why the cost of the unit is also supposed to be decided. So these are some of the major criteria on which you can go for the selection of the microcontroller, but there is another criteria on which you are need to focus upon before the selection of your microcontroller. So this second criteria is how easy it is to develop the product around a microcontroller, means what are the availability of the support that is available in the market for the given microcontroller, in form of whether the assembler is available or not, whether the debugger is there or not, whether the code is efficient, we are having a compiler which can support a C language code or not, or a higher language code or not, or whether emulator is available or not. So all these kind of things, yeah, it would be deciding that whether you can go for this particular microcontroller or not. Okay, and finally the third criteria is the ready availability of the controller at a time of the requirement, in past, in present or a future. Okay, so for small designer it is more important than the other two, because whether you, if you have selected that this is a microcontroller I'm going to use for my project, and yeah, you find it out that after 6 months this microcontrollers are not available in the market, then it would be creating a lot of problems. So first of all you need to be potential of that whether there is an availability of the microcontroller or not easily in the market. Okay, so now let us see the point of difference. So I think I have made it very clear that what is microprocessor, and also I have made it already, we have discussed what is microprocessor. Okay, so now it's very right time to discuss the point of differences between the microprocessor and microcontroller. Okay, so the first point of difference between microprocessor and microcontroller is in microprocessor, CPU is standalone. Means RAM, ROM, IO, timers, they are all separate from the CPU in your microprocessor. Already we have discussed that in microprocessor we are having a CPU which is on the chip, and the other peripherals they are outside the chip. But in case of microcontroller, we are having CPU, RAM, ROM, IO, and all the other devices such as timer counter, ADC, DACs, all they are on the single chip. Okay, so this is one of the most advantage of your microcontroller, that all the things that are available on the single chip. Okay, the second point of difference is designer can decide on the amount of ROM, RAM, and IO ports. Means now, yes, it is up to the designer that what can be the size of RAM, what can be the size of ROM, what are the number of IO port that are to be connected to the microprocessor. But in case of microcontroller, it is fixed. Means on chip you cannot extend your ROM, you cannot extend your RAM. Means if I'll say that this microcontroller is having 1k of RAM and 32 byte of ROM, kilobyte of ROM, then that is fixed. Means you cannot go for the extension of it. But in case of microprocessor, yeah, you can go for the extension of the RAM ROM on basis of your requirement. Okay, if I talk about a microprocessor, they are expensive. Okay, microprocessor, they are a little bit expensive. But in case of microcontrollers, in case of microcontroller, okay, for applications, it is with the cost and the power space are critical. Means it is yeah, it can be a low cost kind of a thing. Okay, means if I talk about a microprocessor, versatility means the single microprocessor can be used for various different tasks. Means multitasking, already we have talked about this thing in the section when we were talking about microprocessor, that it is what versatile means. You can use it for different purpose. Okay, but if I talk about a microcontroller, it is single purpose. Means you can say that it is single tasking kind of a device. Means it is being designed, it is implemented for a single task. But in case of microprocessor, it is general purpose. Okay, the other point of difference is high processing power is required. Means it is having a very high processing power. In case of microcontroller, it is having low processing power. Means high processing power, yeah, already we see that if I talk about a microprocessor, n number of applications can be opened at a single point of time. Means you can have a different section of a CPU which can be allocated for performing the different processing. But in case of microcontroller, no, the processing power is very low. Okay, so this is the advantage of a microprocessor, this is a disadvantage of a microcontroller. Okay, but if I talk about a microprocessor, it is the power consumption of a microprocessor is little bit high. And if I talk about a microcontroller, the power consumption is little bit low. So in all, this can be seen from the different angle also, that whenever you will be finding it out that any device is or a gadget is having a microprocessor within it, you will be finding it out that it would be plugged devices. Okay, but if it is a case of a microcontroller, you will be finding it out that it is battery powered backup devices, because yeah, power consumption is an issue. Okay, now if I talk about the instructions, okay, so instruction set focus on the processing intensive operations. Means you will be finding it out a healthy instruction set which focus upon the processing of the data. But if I talk about a microcontroller, the instruction set focus upon the control and bit level operations. Okay, bit level means generally we find it out that dedicated registers are for the dedicated IO ports, and if I want to control a particular IO port, okay, then a particular bit will be helpful for controlling that particular IO. So a bit level operations are generally being focused upon in your microcontrollers. Okay, typically the microprocessors generally nowadays in use, they are either 32-bit or 64-bit. Okay, but if I talk about a microcontroller, they are generally 8-bit or 16-bit. So it is not being limited that a microprocessor cannot be of an 8-bit. Yeah, we already seen that 885 We can also see 8086, which is a 16-bit microcontroller. Then there are 32-bit microcontrollers. Okay, Intel iprocessors, they are 64-bit microprocessor. Okay, and microcontrollers, they are generally of an 8 bits, but it is not the case that you cannot have a 32-bit microcontroller. Yeah, you will be finding it out in future or in the very next coming classes, that there are microcontrollers which are of the 32 bits also. Okay, this microprocessor, they are typically dip pipeline, which are 5 to 20 stages. Okay, but in case of microcontroller, they are typically single cycle or two stage pipelines. Okay, we can see the same thing from different angle, that you will be finding it out that the instruction that is to be executed by a microprocessor, they required 10 t states also, or 10 machine cycles also, or 4 machine cycles also. But typically you will be finding it out in a microcontroller that the instruction will be executed in the single cycle, or maybe a two stage pipelining. We will be seeing this two stage pipelining very soon in our AVR microcontroller. Okay, so these are the point of difference between the microprocessor and a microcontroller, and I hope I have made it very clear in your mind. Am I clear, my friends?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay, so this is all from my side for today, because my main intention of today's lecture was to get you an idea of what a microprocessor is, how it is different from microcontroller, and what are the point of difference between the microprocessor and microcontroller. And I hope I'm successful in achieving the task of explaining you what is the point of difference between microprocessor and microcontroller. Yes?
Yes, sir.
Yes, sir.
Okay,
Yes,
so
sir.
this was general introduction to a microcontroller. So in the next coming class, we will be talking about a specific microcontroller that we are going to focus upon in the whole semester. That is AVR microcontroller, and we would be taking at Mega 32, which is an AVR family microcontroller, as a reference to study the AVR family. Okay, so I'll be introducing this AVR family to you in the next class. I hope you understood it. Yes?
Yes, sir. You did. Yes, sir.
Okay, so see you in the next class with the fresh topic of AVR microcontroller. Thank you, everyone.
Thank you, sir.